Hello class, and welcome to Chapter 2 in our Introduction to Switch Networks. I've pared down the slide deck considerably for this screencast. I put the full slide deck inside your folder for you to look at. There are a lot of configurations that I won't present here but are in the other slide deck that you might want to try. A couple of them will come in the labs, but it's worth going through the slide deck as you read the chapter to be sure you're getting full benefit from the information provided. But in this brief cast, we'll talk about basic switch configuration and switch security. So the switch boot sequence is much like a router, and it's not too different than a computer. You have your power on self-test or post, and then the bootloader software kicks in, and the loader initializes the CPU, and then the flash file system, and then that loads the OS, takes the default operating system, puts it into memory, and then the switch is run by the IOS, and that's what we interact with when we're interacting with the switch, is the IOS. Now, if there's a crash, you can use a bootloader to manage the switch. If the iOS doesn't work, that's in the full slide deck and also in the chapter, so be sure you capture those details for the test. Now, in this course, you don't have a switch physically with you, so here's a good close-up shot of the LEDs on a 2960 switch, and this is a bit outmoded, but it just might be on the test. So I'm just showing you a 2960 switch is still in use, but we're moving beyond them a little bit. But the idea for all of them is that they have LED indicators that tell you what's going on inside. Now, mostly the port status LEDs are all you see. They're flashing on and off if data is flowing through them. But they can also turn amber and tell you when spanning tree is in process, and we'll talk about that in another chapter. But these are all the duplex mode. The LEDs for status, duplex, system, speed. Power over Ethernet is PoE LED. That tells you if there's for example, a remote Wi-Fi station getting its power from the switch, that LED will be on as well. Now, with basic switch management, you'll be doing this in one of the labs, but so you have to configure it to access a network. And if you're going to be on a network, of course, you need an IP address and a subnet mask, and a default gateway if you're going to be outside the network. If you need to access it from a different network, that switch has to have a default gateway in order to get data back to you outside in another network. Because you can manage it, and because it has an IP address, doesn't mean that it will do anything besides be a switch. It doesn't route any layer 3 packets or anything like that. It just has an IP address so that it can be accessed as a switch on the network. Remember, we have duplex communication and half duplex. Send or receive is half duplex, but only one at a time. Full duplex means you can do both. That becomes important when you set up the port status, because both ends of the cable have to have the same duplex mode on. Otherwise, you'll get an error. So, one of the first tasks you'll do in the labs is set up a switch mode. Now, you notice they're both F01 and F01 on switch 1 and switch 2 are both in full duplex mode. Those modes need to match. All right? And then there's a little how to set up the duplex full. If you get an error on the switch that needs setting, well, just change it to duplex half and see if one end comes up. If not, try the other switch. MDIX is a feature that should be on all of the switches we're using now, but it wasn't always there, and that's because sometimes you'd have a crossover cable between switches, and sometimes people would use an Ethernet cable for that. So the Auto MDIX is able to sense what kind of cable and what kind of connection it has on the other end of the cable, and if it's to send, then it switches over and reroutes. So that Auto MDIX is a way to enable that and turn it on. But in the newer switches, it's on by default. Now, you remember some of this from the router in the last class, the show commands. show running config, show flash, show version, so show history. This is pretty standard. I mean, the show commands aren't very different from looking at a router. So when you're in your switch on NetLab, take a look at these. I highly recommend you doing the NetLab switches right now. Of course, you can use Packet Tracer, but the NetLab switches will give you plenty of good experience with real switches. These are some problems you can get along the way with switching. You can get packets that are too small or packets that are too big, and collisions depending on how many hosts you have, and then late collisions with jammed signals. You'll get this, the runts and giants are obviously the too small and too big, and they get dropped. All right. So if there are problems, then you have to look for electromagnetic interference or some other issue along the way that's dragging the network down. When you're troubleshooting your interfaces, you've got to take a pretty methodical approach. You have no connection, so look at that, show interface, the first thing you do. Make sure your connections are up. Make sure, of course, there's a physical layer you should always check first. Make sure your cables are good. In the NetLabs, you don't have to worry about that. Check your interface status. If it's up or down, fix it if it's wrong. If it's up, check for noise. And if that's not it, check for collisions. And these, the show commands that we saw a little bit ago will help you see all of those. And as you go through the chapter, you'll see the outputs associated with those commands. The SSH operation that you can use in Windows also works in Cisco. You've been using the SSH. I'm bringing it up because it might be on the test, but remember SSH uses port 22. Telnet uses port 23. We like SSH now. Telnet is passé and out of date. You did this lab, something similar to it in the last chapter, establishing security with the crypto key RSA, creating a password level, and then transport input SSH. That's how you configure on a switch as well. You did it on the router before. And again, security concern MAC address flooding. We'll talk about it now because that's what happens when it attacks a switch. Remember, all new addresses or MAC addresses that the switch doesn't know get flooded out all ports. And so if the CAM table gets flooded with bogus switch names, then it keeps flooding out all ports and doesn't register anything out there because those MAC addresses don't exist. And it fills up the switch so much that the switch acts like a hub, just pushing out traffic with no discrimination, totally ruining the purpose of a switch and probably taking down a network. Other security concerns, and this is a bit of review: DHCP spoofing and starvation, fake DHCP servers, and or using spoofing to deny service to a legitimate DHCP server. All right? Those are some of the security concerns on a router, but they can also happen on a switch. One protocol that you probably haven't used yet, and you're going to, is CDP, Cisco Discovery Protocol. It's a proprietary protocol used on Cisco switches and routers. Any Cisco device can speak to any other Cisco device, and it shares a little bit more native information. It can tell you what port you plugged into and what port the neighboring device is plugged into. The cable, goes into the neighboring device. And then it can give you different levels of detail if you ask for a CDP neighbor command. It can give you some IP address and other things. It can save you a bit of work trying to map your way around the network. Here are 10 best practices. I'm going to ask you to hit the pause button to read them. I'm not going to read them to you here because you know a lot of them, and that's what the pause button is for on these screencasts. Securing your unused ports. This is the second lab you'll be doing. You'll be going through and disabling ports, shutting them down, and you'll be taking care of some DHCP snooping and see how that works, to whether you can trust or limit DHCP as a function so it doesn't overrun the switch. And a few security areas you're going to try. The switch security lab is pretty important. You'll be doing secure MAC addresses with static secure, dynamic secure, and sticky secure. And here's what those mean. Violation mode. Now, if something goes wrong, if there is say more than one allowed MAC address on a port, it will shut down. That port will go into violation mode, and you have to put in an error disable, take down the interface and bring it up again. Okay? So, because then when it's sticky, it'll learn the first MAC address and then just stick with it, and it won't allow any others. Okay? So in that disabled state, you have to bring it up, and you'll see this output when you do your labs. But the port error disabled doesn't work, and you have to go in and show the port, and then when you see what's down, you can shut down the port, bring it up again, and reset the security. All right? And that's shutdown and no shutdown. That's the only way to fix a security violation. Another little fun protocol you'll see is the NTP, network time. Put that on a router or a switch, and every one device becomes a server and the rest become clients. So you can determine who the master and clients are and where they will get their clock from, time of day, etc. And that's your NTP status. So that's it. That's a very brief. Now there's a lot more slides, as you'll see. But I wanted to give you just a preview, give you enough to get going on the chapter and maybe get going on the labs, so that you can dig deep into switches and get to know them as well as you do routers. Okay, enjoy the labs, and we'll see you in class and work on those together. Thank you.